Okay, in this video, we're going to be doing Calc Problem Set 70. The problems in a playlist are in the description below. Let's do the problems. First up, we want to evaluate the integral of, or the antiderivative of, x cosine of 2x squared dx. So this, to me, looks like a classic u-substitution. I'm basically integrating cosine, so the answer is basically sine. But how do I balance this stuff out? So I'm going to say that u is equal to the thing inside of cosine, the argument. So u is 2x squared. The derivative of 2x squared is 4x, so it'd be like du is 4x dx. But really, I want 1/4 du is x dx. The reason I want that is that if you look at the integrand, there's an x, there's a dx. Those we have to account for, so we have. And then cosine of u will be on its own. So that's good. So the reason we have 1/4 du is because we really got du is 4x dx. All right, so now we're going to make all of our substitutions. X dx becomes 1/4 du, and I'm going to pull out the 1/4. So 1/4 integral cosine of u, and then du. And then if we find the antiderivative of cosine of u, we get back to sine. So it's going to be 1/4 sine of u plus c. And then u is equal to 2x squared. And so we get 1/4 sine of the quantity 2x squared plus c. Hopefully these are starting to be kind of straightforward to you. I mean, over time, you just get more experience and it's just a little bit easier. If they're not, just like seek out a lot of practice problems and do them. I have a ton of videos on using u-substitution. Definitely recommend that you get really good at that. Maybe like this is a problem that I would have done in my head if I wasn't making the video. And it's okay if you can also do that. All right, new problem. Derivative of the square root of something is 1/2 that thing times the negative one to the negative 1/2. That thing is arctan. The derivative of arctan is 1/1 plus u squared times the derivative of u. That's basically what we're doing here. So let's see if we can do it. So we're going to go 1/2 thing, which is arctan of 4x, to the negative 1/2 times the derivative of the thing. The thing is arctan. The derivative of arctan is 1/1 plus u squared. So that would give me 1/1 plus quantity 4x squared, which is 1/1 plus 16x squared, times the derivative of 4x, which would be 4. So we really just get 4/1 plus 16x squared. I don't see any value in simplifying this any more than it is, so I'm just going to leave it as that. Let's take a look at the next one. If y is equal to the square root of 12 plus u, u is equal to v plus v squared over 2, and v is equal to the natural log of x. We want to find dy dx when x is equal to e squared. Okay, so one thing we could do is we could rewrite this so that y is actually explicitly a function of x. That's probably not the easiest way to go because we also know the chain rule, y is a function of u is a function of v is a function of x. We can find dy dx using the chain rule. Dy dx is going to be dy du times du dv times dv dx. So now the issue is we're supposed to evaluate when x is e squared, but if x is e squared, I'm going to need to know what v is so that I can find du dv, because du dv is going to be a function of v. I'm going to need to know what u is because dy du is going to be a function of u. But we can find those things, right? So let's find our derivative. Dy du is 1/2 thing to the negative 1/2 times the derivative of the thing, but the derivative of 12 plus u with respect to u is just 1, so nothing there. Du dv is going to be 1 plus v, so that's 2v divided by 2, so that's where it's just v. And then dv dx is 1/x. Now we need to know what to sub in for each of them. So x is definitely e squared, that's given. Which means that v is e squared plus, no it isn't, sorry, which means v is the natural log of e squared. And then that's exponents become coefficients, so 2 natural log of e is 1, so that's just 2. And then to find u, I have to take the 2 that I got there and plug it in, so it's going to be, to find u, to find u, I was trying to find y in my mind, but I don't need that. U is going to be 2 plus 2 squared over 2. 2 plus 2, 4. Okay, that was hard for me. Maybe not for everybody, hopefully. So really, I'm going to evaluate this at e squared, which is definitely just 1/e squared. I'm going to evaluate this at 2, which is 3. I'm going to evaluate this at 4, which is 1/8. And then I should be doing 1/8 times 3 times 1 over e squared, right? Because it's dy du, which is 1/8, du dv, which is 3, dv dx, which is 1 over e squared. There you go. All right, so that's the chain rule, and like a method that not a lot of people like to use, but I love to use it because it's like, it's almost like cheating. You don't have to like directly find the function. You can just get the answer. That's the entire problem set. I hope this was helpful, and good luck.